Okay, here we go with the beginning of part 3 of lecture 11. In this lecture, we've been talking about pollutants and where they come from. We've so far looked extensively at the cars as a major source of air pollution. We've looked at the different emissions from cars that lead to the pollutants that we find and that the EPA has found themselves needing to monitor for public health reasons. All right, the next major source for air pollution are coal-fired power plants. The emissions from coal-fired power plants, first of all, because coal is itself a hydrocarbon, mostly carbon, but hydrocarbons as well in the coal. It's also a major source of carbon dioxide and carbon monoxide from the combustion of carbon. Not unlike the fossil fuels, it's a very similar type of chemical reaction. And in the coal-fired power plants, remember, for a power plant, all you need to do is to get some heat so you can heat water. So the water will turn to steam, so the steam will drive the paddles of the turbine to generate electricity. That's what we're talking about, is a coal-fired plant, a power plant that's going to generate electricity. So we burn the coal in order to heat the water to make the steam to drive the turbine. So the source of the heat is the chemical energy that's stored in the coal. But when you burn coal, coal, of course, is dug out of the ground, and it's not just pure carbon. There's other minerals that are mixed in with the coal. And those minerals don't burn, and what they do is produce ash, bits of ash. It's kind of like when you burn like a log, like if you have a campfire or something. Most of the log is made of carbon and hydrocarbons, and most of that will burn away as carbon dioxide. But when you're finished, you have ashes left in your fire pit, and those ashes are the other minerals, phosphorus and just other minerals that are found in the living, the wood that did not burn away and form a gas. They're left behind as ash. Same deal with coal. You'll have even silicon, aluminum, phosphorus, different minerals that are left as ash. And because the coal-fired power plant, the way it goes is you have these huge smokestacks, and so the ash is very tiny particles, and it gets carried up and out the smokestack with the rest of the smoke. Now, I must say that in the United States, the ash issue has been reduced over the years because of the Clean Air Act. The stacks, the emission stacks for coal-fired power plants have ways of trapping the ash, but some of it still gets out, and that's considered particulate matter. PM, particulate matter. PM stands for particulate matter. Okay, again, like the lead that I described earlier, it's not considered a gas because these bits of ash are not individual atoms or molecules as a gas has to be, but small little clusters that are very, very lightweight, kind of like dust, and gets blown up into the atmosphere. All right, another problem with the coal-fired power plant is coal contains sulfur. And different coal contains different amounts of sulfur. It usually ranges between 1% to 3%. And coal, there's different grades of coal. Like soft coal or brown coal has higher percentages of sulfur than hard coal, or cleaner burning coal has less concentration of sulfur. And there's actually been a lot of talk about how the coal industry needs to clean up their coal. And when you hear that kind of language, what they're talking about is to remove the sulfur from the coal before they burn it. And the reason why is because sulfur is another combustion product of burning coal. Just like we get carbon dioxide when the oxygen combines with the carbon that's in the coal, we end up with sulfur dioxide as a product when sulfur is present, it's hot, it's combining with oxygen, it also undergoes the combustion reaction. All right. Now the problem is, again, like we had the NOx, the situation with in the combustion engines for the cars, because we have a lot of nitrogen present. we form the nitrogen oxides, the NOx's, NO, and then as a secondary pollutant, NO2. A similar thing happens with the sulfur. Sulfur dioxide is the primary combustion product of sulfur and oxygen to give sulfur dioxide. But then in the presence of the ash that's present also together, kind of like the VOCs are present with the NO, the ash, the sulfur dioxide will combine with oxygen to form sulfur trioxide. Okay, so we end up forming the sulfur trioxide. So sulfur dioxide plus oxygen in the presence of ash will form sulfur trioxide. Sulfur trioxide is another one of those nasty, nasty gases. Well, I ought to balance this, shouldn't I? Just to be on top of things. Let me see, if I put a 2 there, that's 6 oxygens. If I put a 2 in front of this oxygen, it's still not going to take care of the sulfur, so I'm going to put a 2 here to balance it properly. In this case, we form sulfur trioxide. Okay, sulfur trioxide is a nasty gas, not unlike nitrogen dioxide, in which case the sulfur trioxide can also combine with water to form sulfuric acid, which is like nitric acid and chloric acid. It's a strong acid, and it can cause a lot of problems.